Alright, ready? Okay, so factor theorem, so we're still working with synthetic division. We're just going to be factoring a little more, so we might have to factor the quadratic by doing AC method or difference of squares or something like that. Okay, so factor theorem looks like this. If basically x minus k, so that's what we call a factor, this like linear thing. If this is a factor of f of x, then f of k equals 0. So basically we're doing like what we did yesterday, proving that something is a 0, so proving that number is a 0. We're doing the same thing, proving that it's a factor. Okay, so they will be giving us that k value. Probably, I want to say 90% of the time it's going to actually be a 0 or a factor, and then we can write in factored form. So we would like to rewrite f of x as like x minus k, and then times like whatever is left over after synthetic division. So I'm just going to put the leftovers right here. Okay. The extra piece to this today is that we're going to factor what I'm calling the leftovers. Okay, so that's our extension to what we've been doing with synthetic division. Okay, so we can determine whether x minus 1 is a factor of f of x. And synthetic division, we're going to be pros at it. We should already be pros at synthetic division. So do you guys know what number is going into this lovely little box that we set up synthetic division for? 1. Since it's written as a factor, we have to change the sign from -1 to +1. And then what are my coefficients? Okay. Alright, so we're hoping for a 0 for our remainder to prove that it's a factor anyways. So the first thing, drop the 2 down. And then what do we do? Multiply. Add. Okay, so is x minus 1 a factor of f of x? No, because we had a remainder of 7, so this is not a factor. What does this 7 actually tell me? We can use the remainder theorem like yesterday. Basically, it's like directly substituting. If I plugged in 1 into f of x, I would get out a value of 7, right? So if it was a 0, you should rewrite this and then try and factor it by grouping or AC method or something. Okay, but it wasn't, so that's all the farther we can go. Okay, here is our next one. So we want to factor this into linear factors, given that -3 is a 0. So we know for sure it's a 0, so when we do synthetic division, our remainder is going to be 0. Most of the times we won't know this number, so that's what we're going to learn tomorrow, is how to figure out the different zeros, so that way I can fully factor everything. Them giving it to us is actually really nice. But we still are going to do synthetic division and factor this whole thing. So since this isn't written as a factor, -3 is in the box. And then my coefficients are what? Okay. And we're dropping 6. Then we multiply. And add. And then multiply. And then add. And then multiply. And then add. Okay. So this verifies -3 is a 0. Okay, but I would like to rewrite f of x using what I have. So instead of writing it as a cubic like what it's given, I want to write it in factored form. So how can I write a factor? How can I write -3 as a factor? X plus 3, right? If I was picking out the k value of x plus 3, it'd be -3. And then I can use this, what I call the leftovers, to write my second part. So how do I write 6, 1, and -1? Yeah. Okay, since f of x started as a cubic, I divided out a linear. So it basically just decreases by 1 power, so it should be to the second power. So if this is completely factored, I could be done. But I should check, can I factor 6x squared plus 1x minus 1? So Kaylee's saying yes. How would we factor something like this? AC method. So A times C is? Yeah. B is 1. Now my factors would be? Yeah. And since I have an A value, I have to write the 4 terms and cut it in half, do the full thing. So I'm just going to focus with that. So the plus 3x minus 2x minus 1. Which we factored using AC method a lot. We should know how to do this. Factor out what you know in the first 2 numbers, and factor out what you know in the second 2. So that quadratic, when you do it, factors to be 3x minus 1 and 2x plus 1. I still need to finish writing f of x, and f of x had that x plus 3 that was in front as well. So I should have 3 linear factors, mainly because it was a cubic polynomial. So based on the degree, that's how many sets of parentheses you should have. Third degree, 3 sets of parentheses. So that should happen every single time. If it was a 4th degree, 4 sets of parentheses. So that's what we're doing today. A little extra piece doing AC method. Nice.